scaled up. Okay, this is how Pizza Hut got organized to sell pizza. This is how McDonald's got organized to sell burgers. Same thing, right? They partition the recipe in such a detailed fashion, and then each one of you just go do one thing, right? If you can do more with unit of time, they give you a bigger chunk, right? But because it's a physical limited, I mean, that kind of job is physical limited, they can only partition that to a certain level that fit anybody who are capable to work. But for our level, it's a little bit different. So for instance, so I have 3 boys, youngest is 4-year-old. No matter how you partition McDonald's work, no work will fit him, right? I have another, the middle one is 10 years old, almost 11. Then I think he can do certain jobs already, right? He foresees his level, he cannot lift really heavy stuff, but he cannot really deal with anything that's cooking, probably. But a lot of things, putting lettuce on it, I think he can do it, right? My oldest, 14 years old, he almost can go work for McDonald's, right? Once he's 15, he can go work, right? So yeah, so basically every job there, he is kind of qualified, right? So essentially, that's why McDonald's basically based on partition the job so that anybody who are 15 could comfortably do it. Not comfortable, they actually make you work, right? It's not comfortable, it's just that you're capable, within unit time, you can actually do it, right? Same thing here. How we partition a software engineering project, software coding project, into pieces everybody here are comfortable to work with. That's it. How do we do that? We take the requirement, basically what is needed, then we start creating that hierarchy of partition. What is the ingredient of the partition hierarchy? Classes. In object-oriented programming, it's classes. In Java term, it's classes. Okay? That's what we're going to talk about here in this chapter. All right. So essentially here, so certainly we are just going to. So there have been a lot of approach to do this, but in the end, we are trying to identify what are the ingredients, what are the top level objects, classes, components of our system. Okay. So here is, we are getting a deeper understanding of the requirement. At the same time, we are going to describe them in a way that's maintainable design implementation. Basically, I can partition the work out for me, for myself, and for you to work on it. All right? So there are basically 3 kind of things we are looking for. Okay? I mean, in computer science, actually there are just 2 kinds of things. One type is data. The other is operations on data. There's nothing else. There's nothing else, okay? In computer, I mean, whatsoever, I mean, no matter what kind of computer you have, what kind of program you're looking at, you are just looking at data and operation on data. Okay? That is our model of computer. Our computer, so you probably have studied in some class our computer architecture called the von Neumann model. What is the von Neumann model? Von Neumann model is basically data in, operation in, you take the operation on the data, then you have output. Okay? The whole computer science is based on this. You have data in, you process the data, you apply some operation on the data out. You may say, no, that's not it, right? But this guy doesn't behave that way. It does. It does. What are the data? What is the data this unit right here is processing? This is the computer. This is a data processor, okay? That's why it's called computer. Computer is just compute. What is compute? You have data, you compute. You have digits, you compute. Right? What is the data going this box.
The display, the computer display.
No, that's actually output.
Ah, the buttons.
The buttons. Hey, like this, I'm actually generating data. Right here. Right here. This is generating data. I'm pretty slow. This machine doesn't allow me to go fast either. But I'm actually generating data. Actually, I, as a user, is generating data to this computer. This computer is actually fairly simple. If I push on this button, data in is 0 and 1 in, represent to him, to the computer, is representing something. It's saying that I need to toggle that screen. If I push again, toggle again. Push again, toggle again. So the operation is, if I see this data, I'm going to toggle that screen. It's actually, if you call somebody from ECE over and say, can you implement that functionality for me using a circuit board? You'll say, yes, it doesn't even require a circuit board. Okay? You can actually use some very basic components and just construct a controller like that. Right? But this controller is actually, this is our input 1, input 0. Input 1, input 0. That's output 0. This is output 1. Aha, this guy is just processing the data I'm giving it to it. My data is super simple. It's either 1 or 0. Guess what? That's the base of our computer anyway. Our computer only recognizes binary digit string. Okay? It's our job to actually give meanings to those strings. Either input or output. The meaning are given by us. Okay? But the computer is very dumb. It just processing the number. Just crunching the number. Happen to be the number is crunching has different meanings. Right? Can be displayed on your computer, can be on your phone, can be anything. But you are crunching numbers. That's why it's originally called computer. Right? It's just compute numbers. But the way, so human being was very innovative to map many problems into numbers. Then we process a number, means that we are processing a lot more information, right? For instance, if you take a picture, right? The picture is actually a bitmap stored inside in your cell phone. And your cell phone knows how to process that image map and display on your screen so you can see it. Okay? That is the process. So there are 3 kinds of classes we need to identify. Number 1, entity class. Number 2, boundary class. Number 3, control class. I mean, I think you now by the name you have a vague idea of what they are. We'll see how exactly we do that. Entity class. Basically, this is the way we store information. This, if I do this, this thing actually, no information got stored. Okay? Because this device doesn't record my behavior. It's basically saying, if you give me 1, I will immediately display 1. That's it. I'm done. For good. Right? How about if your computer never store any information? What will happen? What will happen? How about your computer, your Apple computer, great Apple computer, never store any information? What will happen? You wouldn't be able to do anything, and you're probably going to return it to Apple, right? So, first of all, we need to be able to save information somewhere. You may say, okay, great, my computer saved information for me. Your computer didn't save that information for you. A poor programmer in Apple actually implemented a program which actually helped you save your information. That program actually was instructed, coded by someone just like you to help you save your information. Okay? So computer is to process data. So data is today, as you all hear from news and all kinds of things, is actually the most important resource on earth. Data is the most important resource on earth. If you don't have data, you have nothing. Basically, why? Because the money you have in your bank is also data. If you don't have access to that information, you know what's going to happen. Yeah, you may still have a few dollars in your pocket, but that wouldn't last you a few days. And you would hope Wells Fargo still open up tomorrow, and then you can pay your bills from Wells Fargo, and you can withdraw money from there. So critically, that's why we talk about entity class first. Entity class is actually at the core of everything, because that's how you save information. If your computer program doesn't save any information, I think the functionality of this program is very limited, just like this. That's it. If your phone doesn't save information, what is it good about? Remember the very phone you probably used, your home phone, with basically not smart at all. Basically, you plug into the wall jack and you can call somebody. That phone is actually not saving any information. Okay, but you know that's the only functionality you can do with it is to call somebody. Right? Then you have to type in all these phone number yourself, or you have to put a note card next to the phone, have your most favorite phone number on it, right? That time long past, right? That is the situation when your phone is actually dumb and it doesn't save information. Entity class is important. For instance, here, your account information. I mean, if you have an account with a bank, you better have the password and everything you can go to get that information out, because that's your money. I mean, probably not many of you have reinvestment at this stage, but eventually you will have it, because once you start working, you would have to start investing for your retirement, because the company you're going to work for are probably not going to give you a lifelong pension, right? So for instance, you may have heard about all these arguments about PERS. PERS is actually a public employee retirement system, right? It's essentially an investment account. Not an investment account. It's a pension. Originally, it was a pension account for public employee, like our governor, okay? Or everybody work in that building. Oh, actually, right above us, right? The city building. People there, they actually have pensions, right? But fewer of us will have pension. For instance, I don't have a pension. I only have a 401k. Oh, actually, for people who are working for higher education, it's called 403b, right? The same thing with 401k, essentially, which means that you can take a part of your pay. For instance, this year is actually 18,500. You can put that in your investment account. You buy some bond, you buy some mutual fund, you buy some stock, and hopefully it will grow. Okay. So essentially, the idea is you put it in this year. Every year it will grow somewhat, and compounding. Then eventually you'll have money to retire. Okay. That doesn't work always, I can tell you, right? For instance, 2008, everybody lost at least half of their pension, their investment, right? So it's not guaranteed that you'll have that. But hey, this information is for your retirement. It's better to be kept somewhere. So if you are implementing that system, you better have a long-lasting class which will hold on that information. Your database, so if you say, oh, I really want to take database classes. Yeah, database is basically a glorified class which save your information. Okay? You need to know how to use a linked list to save your information first, before actually a database would make sense for you. Okay? Actually, to be honest, at the very beginning, people are just using array and linked list saving information. No database. Database was when we have so much data. Okay? Using linked list and array to save this information would be way too cumbersome. So we actually invented some system called database to make saving data a lot easier. Okay? However, these are entity class. Basically, these are permanent class items in your system which will be there as long as your system be there. For instance, my class project to you, you have to keep the chat history for me. That is long-lived information. If I'm ever sign up on your account, that information should be available to me. Right? If you go to Gmail, although it's a free service, you expect your email be there, right? So if you design a system like that, you better make sure to keep this long-lasting information. All right? We have boundary class, which are essentially model interaction between your product and environment. A boundary class is typically associated with input and output. Great. This is exactly what we talked about last time, right? Your chat app must have some interface to talk to the user. This is essentially, boundary classes are essentially your user interface. Right? How about my system have no interface whatsoever? What will happen if my system have no interface whatsoever? It doesn't have any boundary class.
And no one will be able to use it.
Exactly. That's a useless class. That's a useless system. So you must have boundary class. Okay? So we have two things that you must have right now, right? If you don't have a way to save information, yeah, your system functionality will be really limited. If you don't have a way for your system to talk to user or other system, it's a useless system, according to you, right? If your iPad say, okay, I give you a box, just a box, no interface, no screen, no button whatsoever, but this is your computer. Well, if Apple is trying to sell that to you, I don't think you guys will go buy it. Okay. So for instance here, if you have investment, you better have a way to retrieve that information. That's why when you go to a bank, the teller will ask you, do you want a balance of your account after you deposit money? Most of us say yeah, no, we don't need that. But hey, at least, so we know that, and we do that because we know we have a way to retrieve that information. Okay, all the time before we have online banking and everything, everybody actually asks for that information. Why things changed? Okay, that kind of receipt, if you look at it, basically 20 years ago, nobody actually reject that kind of receipt. Why? 25 years ago. When you go to the bank, you actually ask for.
That was the only way to know for sure.
That's your only proof. On that day, you have this much money in your account. Okay? It's not like today. If you go to online banking, open up on your phone. I have this much money. I know it. Right? So that is interface. When we don't have a computerized system, that's the only interface we have with the banking system. Right now, you can look at your mortgage report, you can read investment report, but you need a way to look into your information. Okay? That's why you need boundary classes. Control classes. This is for model complex computation algorithm, right? Control. Well, sounds really complex, but it's not. Basically, this is a job you're trying to achieve. A major piece of the job you're trying to achieve in your system, right? For instance, let's look at something really in fashion today, machine learning system, all right? I think most of you guys probably don't know how machine learning system actually works, but I bet every one of you have heard about machine learning system. Okay? So how exactly a machine learning system works? It has a called image recognizer inside. We don't care what kind of, how they actually build that thing, but it's a computer program. The input is the image. I mean, I'm using the most simple ones you've probably seen thousands of times. You input the image of cat, okay? Then the output is the cat, okay? This is our ML system in a nutshell, okay? So the input, okay, let's see. So here, we have a image into our ML system and give you an answer. Okay? All right. Indeed, this thing actually have a very complex network called neural net, which you don't really need to know at this point, right here. Something like that inside. Okay? So your system this is a great example of our boundary class and our computing class and our entity class. Why? Okay, this image, answer, what are they? What kind of classes are they?